Welcome to a new test and teardown video. This time it's a World Precision Instruments DVC-1000 voltage current clamp. At first I did not know what the heck is this instrument doing, and it's absolutely not obvious when you're looking at it like that, right? Let's first have a little look here. Okay, so we got some voltage amplifiers, some currents, and timers, and you can hear voltage or current. This is of course the meter, and since we got 2 meters and 2 measurement setups, so the reason is this one is a science lab instrument for working with animals, not with humans. That is explained on the back. I will show you in a minute. So you can do all sorts of science lab and tissue experiments with this unit. And the idea is you have a test sample on one of them, and you have the real sample on the other one. And then you perform your experiments, write down everything, and then you get your results. And I think the idea is you don't even know which one of these is the actual test and which one is the actual control sample. And this way you can easier prove your point of your experiment to be right or wrong. So it's definitely an interesting instrument. I don't have any of the probes. I don't have any of the special samples. You need to connect to your tissue samples using conductive fluids and all sorts of funny silver wires and whatnot. It's actually really complicated. And the mains cord is cut, so I think it is not working at all. So what I want to do is I want to open it and investigate and see how it is designed. And then we'll probably figure out if we will be able to power it on or not. So here on the back, here is the World Precision Instruments and the model number, la 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 la, and all that is fantastic. Can't really read anything here. What is it they are trying to say? No. And here is the thing. This device is for investigational use only in laboratory animals or other tests that do not involve human subjects. You know, that's important. It's actually not that bad designed inside. I've got a very big main board, and the circuit board layout is like super duper old school with really fat traces, as you can see here, all over the place. And this is all micro nano currents, but they just made it like that, right? So the power supply is up here. Oh, look at that. We got a little pet inside. Hello. You want to be a part of the video? Are you done? Can you move along? And then a very big transformer for those micro currents. I mean, really? Why would we need such a big transformer? That I find a little bit funny. So there's a shielded cable. I think this one goes to the, where's the main power switch, right? And then we got a lot of really cool analog circuits right here. So that will be a GG211CJ, and those are quad analog switches. So it's of course for directing the different measurement signals. And we got some op amps, LF356, really nice, a single op amp with JFET. Where's the 4047 multi vibrator oscillator timing device? Isn't there like a 47 once again? So it's the same circuit mirrored on the other side, right? And then there's a little plug-in. Oh, can I get closer to that? So that one is the LF411 op amp. So they're using some really cute op amps. That's probably a current generator. Is what I would expect with those transistors and high precision resistors and all that kind of stuff. And even the power supply is made using one of those really nice chips, the 729, or is it? They come in actually in several different types. Yes, the 23, right? And they got a very high precision reference in them. So when you are using those as a little voltage regulator, you can use, of course, external transistors and for current and voltage regulations and all those kinds of things. But you get a very good stable supply, and that is, of course, what we want. Here's all the output voltages. Some of the less demanding supplies just come from the good old normal regulators. Tons of capacitors and all that. But I don't find anything leaked. There's no nasty burnt or anything like that. The front panel, well, it looks a little bit like a prototype or a low volume production. You can see all those wires, tons of soldering, and you wouldn't really want to high volume a design made like this, right? High precision burn potentiometers, that is all goody. That will be a standard LCD panel meter and a custom scaling board and custom connector to fit everything. They really love to use those type of connectors for all that kind of stuff. So obviously they plug in a little scaling board for this panel meter, and that is of course perfectly fine. I mean, it's not too bad or anything. Yes, all the ID codes of the date codes of all the ICs, everything is from 1985. So I believe this is what I will call this unit. Yeah, I think we'll try and power it up. There's also a good news about the voltage selector is for 230, and that is a good point. This is really something you want to check for as well, right? Oh man. So this is the mains power cable, and look at that. It's shielded. Here's the shield connection, and it's really the thickest. You can drive, I don't know, 16 amps from these wires, and it's also made like that in here. So yes, definitely medical grade shieldy super duper. So I don't know exactly what to expect, but hey, let's try and power it up and see if I can play with the different voltage and current generators. So here's mains applied, and it's not using any kind of power. So far so good. And then we'll see it's using 19, 17, 16 watts, and it really worried me a lot because it used 50 watts the first 2 or 3 seconds. So I think there was a leak in one of the capacitors, and it somehow is not there anymore. So it's okay. It's going backwards and between these two different. Okay, so we got that as the time. So let's go 1 second. 1 second. Okay, that seems to be working. Overload, we got some. Okay. Amplify. So this is probably the. What are we doing? What are we looking at here? I don't know anything at all because we don't have the probe. But what I could do is, of course, plug in a DIN connector or something like that. Now the other overload is up and running. So we got some voltage. We got push to adjust. We can. Oh, here it's reading some stuff. Maybe we should try and put some. Can we see? Okay, now we can see what we're doing, right? And then, okay, let's see if we can understand this. Haha. So we got some stuff going on here, right? Ah, ha, ha, ha. So this is the current or the voltage in millivolts, right? And then we can go and... Oh, those switches are like really tough. So are we here? What are we doing? Fluid compensation thingy thungy. Nah. Oi. This is not a normal DIN. This is a multi connector with tons of oh no, so I can't really do anything with this. It's just annoying. It's not even funny anyway. I just wanted to show you guys what it really consists of and stuff like that. It's nay. Not funny in any way. So I'm now in voltage clamp mode, and I can adjust set the clamp voltage. And it seems like there's a decimal point here, and everything here is in millivolt. So why is this meter? This is just a random decimal that is not necessarily there, right? Because I mean, this is the voltage that I measure in the probe. It can, of course, be they send out a voltage that is a factor of 10 higher, and then it's divided by 10 in the probe, and then the actual voltage to your subject is then this 47 it displays. I mean, that is it's very likely, because you don't want to transport really low millivolt voltages via connectors and cables and all sorts of stuff to your actual experiment, and this way it's much more accurate the way. So what I can see here is I can set the voltage. Oops, so this is the maximum, and if I go to timer, it will be timer control, and the setup here switches between this and that to my test for whatever reason. I haven't yet figured out. Probably this is this. Can I multiply my time by 10? Yes, I can. So wow, you can run some really long 500 seconds. How is that done? Because I don't really see any. Ah, yes, I did. That will be the capacitors in the middle that's doing all this. Of course they can do that. Okay, that explains a lot. Well, and then you have if I move the points, if I move my meter to, I think it was up here, right? Then I have my, was it those two, right? See, and there I have the test current, and then how did I do this? The current was over here, right? I don't know exactly what I'm doing, to be honest, but I think the unit works more or less, but I just don't know what to do with it, really, honestly. It's probably gonna go back to my fantastic storage of funky old equipment I don't know what to do with at the moment. I was hoping for some fantastic stuff with a Z80 and all sort of funky stuff inside, but it wasn't really that super interesting. I'm sorry if I didn't really entertain you that much tonight. So thank you very much for watching, and bye bye. Better go to bed now.